This project addresses three core business problems. Who are my best customers? What should I recommend next? And how do I act on these insights?
Welcome. For those that are curious and really want to know how this project was built and where it's been pushed on GitHub, so it's available here on GitHub, my GitHub account. All right, these are all the files and directory that make up this project. Okay, just like what I said, Shopper Spectrum is a production ready. That means it's been deployed already. It's a production ready machine learning and business intelligence project for e-commerce. Okay, and the goal of this project is very simple. For customer segmentation and for product recommendation. All right. With that all said, we'll go ahead and look at the README file, the content of the README file. So this is the GitHub repository, and this is where it's been deployed. Okay. Uh, we use Python 3.12 version. We use Scikit-Learn from Python. We use Streamlit for the user interface. We deployed it on render. 180 test was passed, and it's been licensed with MIT. Okay, that all said, so the content of the README has the overview, the problem statement, architecture, how this was built, the features, data set, directory structure, quick start local setup. We're going to see how you can set this up locally after you must have downloaded it and you want to test it on your local computer. All right, we're going to talk about the local setup. We're going to run these going to run the machine learning pipeline on Kado. All right, the Streamlit application. We're also going to run this application locally on Streamlit for user interface. We're going to run text and show you where it's been deployed on render, and we'll talk about the technology used to build this documentation index and customer segment reference. All right, just like what I said earlier, Shopper Spectrum is a production ready end-to-end machine learning system built on UK online retail transaction data. All right. It delivers two core machine learning capabilities through an interactive Streamlit web application. And while the capabilities, one is customer segmentation that uses RFM analysis, KMeans, and clustering. All right, and what happened? It displays four segment labels. Another capability is the product recommendations, which I use the method item based collaborative filtering and cosine similarity, and these produce six similar products with fuzzy matching. All right. So this system follows the patch first machine learning pipeline and streamlined serving architecture. The Python notebook, uh, was used to train and export the model artifacts, right? So, and the Streamlight loads them for real time inference. Why did I do this? Why did I think about building this software? Okay, the global e-commerce industry generate vast amount of transactional data every day. Yet some businesses lack the tooling to translate that data into actionable customer intelligence. So this project addresses three core business problems. One is who are my customers? So with the RFM, which is recency, frequency, and monetary value based segment, it helps to classify every customer into meaningful behavior group. All right. What should I recommend next to my customers? You have customers that they come online, they buy a lot of things from your store. So how do you recommend goods to your customers? The next goods product. How do you recommend what they should buy next? So we are using a collaborative filtering. It helps to identify products that was frequently purchased together by similar customers. Let's say your customer bought a, a set of pencils. All right. So how will you recommend the next product? With the data provided, we saw that people who bought pencils, all right, also bought uh, drawing paper. So you said, okay, since a lot of people that bought pencils also bought drawing paper, we should also recommend this buyer to to get drawing paper. All right. So that is it. Okay. And this is how this works. We have a data which is called online retail CXV. Okay, it's a UK just like what we said, it's a UK online retail transaction data. All right. So we used when the data was provided, I used Python notebook, all right, called Shopper Spectrum to uh pre-process the data. All right. I dropped no customer ID in the data. I've removed cancellations. All right. The cancellations, and also I filter invalid rows. After doing that, I generated different kind of charts. Okay. And when I was done with that, I used the segmentation engine. I used standard scalar, KMeans, PCA, and cluster labels. And for the recommendation engine, I use the pivot table, cosine similarity matrix, and for the recommendation, I recommend 5 products for users. Okay, all right, and this the data with the Python notebook. I use the Python notebook to uh to train models. Okay, and the models I trained was five models which has their own various work. All right, and these models helps to recommend and segment products. Okay, just like what I said here, these models here, they helps to recommend products and also for customer segmentation. All right, so these are the futures model serving. Okay, let's go to the data set. Just like what I said, initially I was provided with an uh, online retail CSV, okay, which is a UK online retail that has data from December 2022 to December 2023. The rows is about for the 1,000 unique customers. These, and inside the data, we also have unique product of about 3,000 and unique countries 38. Okay, the columns in the data include invoice number, stock code, description, quantity, invoice date, unit price, customer's ID, country, and total price. So these are the columns available in the data set. Okay, and the directory structure. This is how the directory structure. This is the parent directory, and inside it we have the app.py, which is the Streamlight web application. This here is the machine pipeline that we use to train and export. our model requirement.txt for our dependencies. Uh, in all that, so this is the model here. So the model directory has these. Okay, the model was generated when you run the notebook. Okay, and these are the models that are generated. So this one is to trained k-means model. The scalar is fitted standard scalar. Uh, Cluster in segments, label, and string, and all that. So we go to the test. Uh, just like a software developer once said, a software product without several tests is a broken software. So 180 tests was passed in 7 files, and this software spectrum is well documented, and the documentation files. All right, let's talk about the quick setup. Once you have downloaded these as a zip file, what is the next thing for you to do? You are to unzip it.